Back to another video on double A learning. Today, we're going to stick to another math concept, but this time we're going to take the root of derivatives. So, derivatives is more of a calculus-based math concept, and I would say you're introduced to this topic around high school, around Calculus AB, if you guys are taking the AP exam, Calculus AB, or like in an introductory calculus college class. So, in this video, I'm just going to go over what is a derivative, how it can be written, and some basic derivative rules and examples with those rules included. Okay, so let's start with the first basic question, and that is, what is a derivative? Okay, so a derivative it measures how fast a function is changing at a certain point. So it basically measures the change at that instant moment. So basically that's called the instantaneous rate of change. So if I were to draw this graph right here, just a rough sketch, this is just a linear line, we know that. What a derivative would tell us is, if we just choose this random point right there, what does that change? What is the slope at that given instant, at that given point? So that's what we're referring to when we think of instantaneous rate of change. Now, derivatives can be positive, negative, or zero. So an easy way I like to remember if a derivative is positive, negative, or zero is think of a hill. So a hill or a mountain usually goes like this, where if you're going up, that I like to think of is the uphill, which is positive. So the derivative of this portion would say is positive at any of these points. And then right here at the top, it's flat. It kind of like evens out for a little bit. So that I have to call it is constant, it's zero. And then when this portion right here, it's kind of sloping downward, it's going negative. So the derivative at any point there would be negative. Okay. Now that we got the basics of what is a derivative and a quick analogy, let's go into how it can be written. So, there's several ways that you can show you're taking the derivative of a function. So, let's just take the original function. You'll probably see it written as f of x. This is what people say is the original function, the main function. So, if we wanted to take the derivative of f of x, what will we do? So, if you want to take the derivative of f of x, you will usually rewrite it as f prime of x. This shows you took the derivative of this to get that right here. Now, you can show multiple derivatives by just adding another prime. Say you want to take the derivative of this f prime of x, that can be denoted as f double prime of x. So you'll probably see most of your if you're given an equation needing to find the derivative, it'll be written as f of x for most of the time. But sometimes it can also be written as y. Y is equal to a certain function. And if you want to take the derivative of y, you'd simply just write that as y and add the prime. And same thing, if you want to take the double derivative of this y, or the derivative of the y prime, this would be y double prime. Okay. And one more way people can write a derivative function would be with a notation of dy over dx. So what this thing right here is basically saying is it's indicating the change in y at that moment and the change of x. And that makes sense because from what I explained earlier, we know the derivative is the instantaneous rate of change. So at that instant, we're saying of y and over x. If that makes sense to you. I hope that's clear. Okay, let's go over some basic derivative rules to know. Okay, so in this video, I'm just gonna go really touch the surface of derivative. If you're taking in high school the calculus AB or BC exam, you'll have to find applications and use these rules to further or dig down. And that's probably the same thing for a college course as well. So, anyways, the I'm just going over the basics here. So the first derivative rule is known as the power rule. Okay, so this rule I think is best shown through an example. So the example I'm going to give here is a really simple one. 3x squared. So I'll write y is equal to 3x squared. We need to find y prime. So how do we do this? So the power rule basically allows us to take the power we have right here and multiply it to the front number we have right here. So when we do this in this case, it'd be 2 times 3. But what we have to do to the power is always subtract it by 1. So this would turn into 6x to the power of 1. And that 1 we don't have to write. We can simply write as 6x. I can give you guys another example just in case that was confusing. So let's take, for example, 5x to the 4th. Okay. Same thing here. Multiply this 4 right here with the 5. So 4 times 5, we know that's 20. So just write 20. And then this one's the original function y. And this is the y prime. So we know 5 times 4 is 20. And now you need to do 4 minus 1 because that's what the power rule implies. So we include the x still. So x goes here. So 4 minus 1, so that becomes 3. So the derivative of this function y is equal to 20x cubed. Okay, that's the power rule. Now let's go to the constant rule. So the constant rule. This rule is, I feel like, the simplest one to understand. So basically what the constant rule is that if we have any y function, y is equal to 5, for example, the derivative of that will always equal 0. So y prime would always equal 0. We can have another example where y is equal to 1000, let's just say. That's obviously a big jump from 5. Y prime would still equal 0. No matter how big you make this number, you can make it 1 billion, whatever, it would still equal 0. Okay. Now, let's show another example. If y is equal to 0.001, y prime, well, that would still equal 0. So what I'm trying to prove here is that a constant, the derivative is always 0. Just make sure you have that rule memorized. Okay. Next up, we're going to get to a little more harder, I wouldn't say harder per se, but a bit more challenging rules that you guys have to know, memorize. Hopefully you have to memorize. Okay, so the product rule. Okay, what is the product rule? So say we have the function f of x is equal to g of x times h of x. Now obviously I'm just using g of x and h of x as an example. These would probably be replaced by actual numeric values with variables, but I just sometimes I know in the calculus AP exams they'll have like g of x and h of x to confuse you guys. So I want you guys to make sure you have an understanding of just what the product rule is, so you can better imply it in your future quizzes or tests that you possibly take. Okay, so the product rule basically says, again, we have to write f prime of x because we're trying to take the derivative of this f of x. So how you would write this would be g prime of x multiplied by h of x plus, there's always going to be plus unless there's a negative, but yeah, but you get the point. It's going to be plus here. Multiplied by g of x times h prime of x. Notice how in the first part it's g prime of x and normal h of x, But in the second part, it's h prime of x, but normal g of x. It alternates, basically. So the product rule basically allows us to find the derivative if two of the equations are being multiplied to one another. So make sure you guys have this rule memorized. And the next rule I'm going to go to is the quotient rule. Okay, so the quotient rule is used when a function looks like this. So f of x is equal to g of x divided by h of x. It's when a function is being divided over something. And how you would write the derivative of this would be f prime of x equals h of x times g prime of x minus g of x times h prime of x all over h of x squared. Okay, so we can see that the product rule and the quotient rule, as the top part, are exactly the same. They except the signs, obviously. So an easy way I like to remember the quotient rule is this little mnemonic. It's low d high minus high d low all over low low. So low, let's go over that again. So low, the low value is right here, low function is right here. So low and d high, the derivative of the high, right here. Low d high minus high, so the high would be up here, d low, so derivative of the low, all over low low, so low squared, and that'd be right here. So that's just a quick mnemonic for you guys to like memorize this rule quicker. And I have one final rule that you guys should be familiar with, and that is the chain rule. So the chain rule can be depicted like this. Y is equal to f of g of x. Okay, so if we want to take the derivative of y, we write y prime, again, is equal to f prime of g of x times g prime of x. So what the chain rule is used for is for composite functions. And you guys will probably see, from what my experience, a little less of these compared to the previous ones that I've shown, but you will still encounter them. So make sure you guys have this memorized once again. Okay, let's get into 3 examples that I have here. Okay, so we're gonna start off with an easy example, and we know, so for this example, I have f of x is equal to 5x cubed minus 2x plus 7. What would be f prime of x? You guys can pause the video and try to solve it yourself, but I'm going to go over it now. So this is simply just the power rule we have to use. That was the first rule I showed, and probably the simplest derivative rule you have to know. So take these terms separately. Take it this one, and this one. Okay, so let's just focus on 5x cubed. What we would do again, bring the 3 here, multiply it to the 5, so 3 times 5 becomes 15, and then subtract 1 here, so it becomes x squared. Okay, moving on. So minus, so what's the derivative of negative 2x? So this x, there's a 1 here, remember. So that 1 is being multiplied here, so negative 2 times 1 would just be negative 2. And then 1 minus 1, that's just 0. So x to the power of 0 is just 1. So this would just be 2, simply. And we know 7, the derivative of a constant is just 0. So we can just write plus 0, or we can just leave it off. So the final answer for this question is this right here. Again, that was a simple example. Moving on to a bit more difficult example compared to the one we did. Okay, question 2. F of x is equal to 2x plus 3 times x squared minus 1. Okay. This is, like I showed before, the product rule, because we have two values right here. Like I showed in the product rule, this would be g of x, for example, and this right here would be h of x. So if you guys memorize this formula, then this problem is pretty straightforward. All you have to do is first write f prime of x, obviously, is equal to, take the derivative of this side, the 2x plus 3. So what's the derivative of 2x plus 3? So that would just be 2. And then just leave the x squared minus 1 right here. Again, we know this because of the product rule formula. And then we would do addition. And now we took the derivative here originally, so now this one we would write as normal, 2x plus 3. And now we would take the derivative of this side. So that would be 2x. Okay. Now, we can't just leave the answer as this. We have to simplify. So, f prime of x would equal, we use our distributing that we know, distribute it here, distribute this. So that would be 2x squared minus 2 plus 4x squared plus 6x. We're not done yet still. We can still simplify. Again, I'm doing this because your calculus teacher will probably want you guys to simplify the furthest. And even in like a multiple choice test, it'd probably have it simplified to the furthest. It's always a good habit to develop. So, yeah. So this would simplify into 6x squared plus 6x minus 2. And there's your final answer. Okay, that was a bit more challenging compared to question 1. So now let's go to our final example of today. This one I would say requires a little more thinking, but it's similar to, if you have the formula memorized, you'll be fine. So this one, we have f of x is equal to x squared plus 1 all over x minus 2. Okay. We see here that there's a function being divided by another function. This is simply the quotient rule. If you guys have this remembered, again, it's simple, just like the last one. If you don't have the formula memorized, it's going to be difficult. So remember the mnemonic, low d high minus high d low, all divided by low low. So let's try that. So low, that's just the x minus 2, d high, so the derivative of the high, which is just 2x. We can find that out because simple power rule, once again. And then minus high, so just keep the high function the same, d low. So that would just simply be 1. All over low low. So we can just write that as x minus 2 squared. Okay, now we have to simplify. I forgot the f prime of x here. Make sure you don't forget it like how I did. Okay, now let's simplify this. Okay, so this would simplify. We'd first distribute these. So this would become 2x squared minus 4x times, and this would just be minus x squared plus 1. Yeah. All divided by x minus 2 squared. Okay. We would still simplify this further, once again, into 2x squared. Now we simply just subtract these terms. So 2x squared, I'm just going to rewrite it first actually, minus 4x minus x squared minus 1, because we're distributing this minus sign to both of these values. And still all divided by x minus 2 squared. Now, we would simplify that even further. So that would equal x squared minus 4x minus 1 all over x minus 2 squared, giving you your final answer. Now, depending on who your teacher or professor is, they might want you to expand this bottom term, but for at least this video, we can just leave it as that. And in the practice worksheet that I'll provide, you can leave it as that as well. So that was it for today's video. I hope it was helpful for you guys. Once again, there will be a basic derivative practice sheet that I link in the comments below, as well as in the next page below it will be some derivative rules. And comment below if you guys want me to do more other stuff besides math or anything. But yeah, thank you for watching.